Hey, this is a review for your Chapter 4 exam, Physics 1. We're going to try something a little different. I hope you find it helps you. Topics that we've covered so far is how do we know if an object's moved, relative motion, distance versus displacement, speed versus velocity, average velocity versus instantaneous velocity, acceleration, 3 ways for an object to accelerate, graphs of distance versus time, distance on the y-axis, time on the x-axis, graphs of velocity versus time, and we solve problems using velocity and acceleration. Other topics, we talked about free fall, we talked about the acceleration due to gravity, air resistance, what affects the amount of air resistance on an object, terminal velocity, when does terminal velocity happen, and then you solve problems with free fall, especially in the gizmo that you worked on. So motion. An object is said to have moved if its position has changed, but there is an exception. Relative motion is comparing an object's motion to another object. For example, if there's somebody standing on the ground and they see a plane go by, let's say at 500 miles an hour, they see the speed as 500 miles per hour. But people on the plane, it doesn't seem like the plane is moving at all, particularly if it was at night and the people didn't have any point of reference. They would think the plane was not moving. However, if somebody on that plane should get up and walk to the front, there's a typo, of the plane at 3 miles per hour, the person on the ground sees that person then moving at 500 plus the 3, or 503 miles per hour. People on the plane only see it as 3 miles per hour. Let's talk about the differences between distance, displacement, speed, and velocity. Distance, how far an object moves. That would be a scalar quantity. Displacement, how far and in what direction an object moves. That would be a vector quantity. Speed, the rate that an object's distance changes. Remember, a rate is a ratio that has time in the denominator. That would be a scalar. Velocity is just speed with direction, and that would be a vector quantity. Average velocity, indicated by a v with a line over it, is the distance an object travels divided by the time it takes. That equation would be v equals d over t. Instantaneous velocity is the velocity of an object is traveling at a certain point in time, a certain instant in time, if you want to think of it that way. Acceleration is the rate at which an object's velocity changes. Okay, change in velocity, remember, is delta v, which is final velocity minus initial velocity. An object can accelerate by one of 3 things. It can speed up, it can slow down, or it can change direction or turn. Graphs. The slope, rise over run, of a distance versus time graph is the speed or velocity of the object. The slope of a velocity versus time graph is the acceleration of the object. A horizontal line on the graph means that the object has a 0 slope, or a 0 rate of change. Here's a velocity problem. Suppose you take a trip that you cover 180 kilometers and it takes 3 hours to make it. Your average speed is what then? Okay, here's the given, our formula, and the work, and you can see that the average speed or velocity would be 60 kilometers per hour. Acceleration. Car starts from at rest. At rest would be 0 velocity. Okay, 0 meters per second. And after 7 seconds, it's moving at 42 meters per second. What is the car's average acceleration? Alright, so we're given that the time is 7 seconds. Initial velocity would be 0. Final velocity 42 meters per second. A equals question mark. Here's our formula. This is VF minus VI is actually our delta V, or the change in velocity, divided by the time. So 42 minus 0 just gives 42 meters per second. Divide that by 7 seconds. You get 6 meters per second squared is our acceleration. Free fall. An object is in free fall if the only force acting on it is gravity. And remember, the force due to gravity we call weight. An object in free fall accelerates at negative 10 meters per second squared. It's actually negative 9.81 meters per second squared. and the negative sign means that it's going towards Earth or down. Air resistance. In the real world, there is air, and there's another force, therefore, that acts on falling bodies. Air resistance, or air friction, and it acts upwards opposite the motion. Okay? The amount of air resistance on an object can be affected by several factors. Two of these factors would include the surface area and the speed. Okay? Terminal velocity. This occurs when the weight of a falling body equals the air resistance on it. So weight would be going down, air resistance would be up. The net force would then be zero, and the object would have zero acceleration. It would continue to fall at whatever speed it was at when terminal velocity occurred. Freefall problems. We learned in the gizmo how to do two types of freefall problems. One, find the velocity after so many seconds, and two, find the distance an object has fallen after so many seconds. Here's a sample, see if you can do it. A freely falling object starts from rest. After falling for 6 seconds, it will have a speed of about how much? Okay, this is all for this review. Hopefully you found it helpful. Thank you.